Good morning everyone. Today onwards, let us discuss about the chapter Semiconductor Electronics. In this chapter, the topics to be covered are Introduction, Band Theory of Solids, Types of Semiconductors, PN junction diode, PN junction diode as a rectifier, special purpose of PN junction diode, and finally digital electronics. So these are the concepts we want to study in this chapter. Now let us see one by one. Okay, first one is introduction. So that is introduction about electronics. What is electronics? So electronics is the branch of physics which deals with the study of controlled motion of electrons. Controlled motion of electrons means we can control the motion of electrons by two types, that is by control the number of flowing of electrons, also the controlling direction of flowing of electrons. By these two ways we can control the motion of electrons. So that branch called as electronics. So that is branch of physics which deals with the study of controlled motion of electrons called as electronics. The development of electronics from tube electronics to solid state electronics. Before 1930, the electronic devices like TV, radios, computers, etc. So these are electronic devices are made up of vacuum tubes, triodes, tetrodes and pentodes. So these are the building block of these electronic devices. Vacuum tubes nothing but, so this consists of two electrodes, that is anode and cathode. So that device called as vacuum tubes. Triode nothing but, this device consists of three electrodes. Tetrode nothing but, this device consists of four electrodes. Pentode nothing but, these devices consists of 5 electrodes. So therefore, these are the basic elements of these electronic devices. In these devices, the electrons flow in only one direction, that is from cathode to anode. The flowing of electron is from cathode to anode. So we control the direction of motion of electrons. So these devices having certain limitations. What are the limitations? First one is these devices operated at high voltage. Nothing but these devices require high voltage. That is first limitation. Second one, obviously, so this required high power, that is these devices consume high power. So voltage is increases, power is also increases. Therefore these devices consume high power. That is second limitation. Third limitation is, so these devices are in bulk in size, so it requires large space. So that is the limitation. So fourth one is, so these devices having short lifetime. So this is also the demerits of these devices. To overcome these limitations, so we developed solid state electronics. So after 1948, we developed solid state electronics. In solid state electronics, these vacuum tubes are replaced by transistor. So transistors, diodes, ICs are the basic elements in the solid state electronics. So obviously these devices having fulfill these limitations, nothing but, so these devices consume less power. so operated at low voltage, having a large lifetime. So also, so these devices are in small in size. So these are the advantages. Of course, in these devices, we can control the number and direction of charge carriers. Here, we can control only the direction of charge carriers. Here, we can control the numbers and direction of charge carriers. So that's why the solid state electronics is updated version of tube electronics. Okay, next concept is band theory of solids. Students, we know that matter exists in three types, that is solids, liquids and gaseous. In gaseous states, the atoms are freely bonded. In liquid state, the atoms are loosely bonded, but in solid state, the atoms are closely packed. So this is one concept. Also, we know about atom. Atom consists of nucleus. Around the nucleus, the electrons are revolve in different orbits. So like this is nucleus, this is innermost orbit, it is innermost electron. So these are the other electrons revolving in different orbits. So this is innermost electron, this is outermost electron. These electrons are having different energy values. So that suppose this is innermost electron having certain energy value. So this is outermost electron, therefore certain energy values. So this is the energy level diagram of single atom. Single atom alli energy level diagram ee tara irutte. Here, so we are discussed about solids, band theory of solids. In solids, the atoms are closely packed. As a result, the electrons of different atoms are interacting with each other. So this is single atom. So therefore, so the electrons of other atoms gets interacting with each other. So as a result, the energy values of all the electrons of solids gets modified and lies in a certain range. So is as shown in the figure. So this is about band theory of solids. ಎಕ್ಸಾಮಲ್ಲಿ ಹೀಗೆ ಕೇಳಿದ್ರೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ ಆಫ್ ಸಾಲಿಡ್ಸ್ ಅಂತ ಕೇಳಿದ್ರೆ ನಾನು ಇವಾಗ ಹೇಳಿದಂತಹ ಥಿಯರಿನ ಫಸ್ಟ್ ಬರೀಬೇಕಾಗತ್ತೆ. ಆಫ್ಟರ್ ದಟ್ ಈ 4 ಡೆಫಿನಿಷನ್ಸ್ಗಳನ್ನ ನೀವು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬೇಕು. ಹಾಗಾದರೆ ನಾನು ಏನು ಥಿಯರಿ ಹೇಳಿದೆ ಅನ್ನೋದು ಇನ್ನೊಂದು ಸಾರಿ ಹೇಳ್ಬಿಡ್ತೀನಿ, ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಸೊ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ ಆಫ್ ಸಾಲಿಡ್ಸ್ ಅಂತ ಕೇಳಿದಾಗ, ಇನ್ ಸಾಲಿಡ್ಸ್ ಲಾರ್ಜ್ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಆರ್ closely packed and hence electrons of different atoms are interacting with each other. Therefore, the energy values gets modified and lie in a certain range. So is as shown in the figure. ಅಂತ ಈ diagram ನ ಬರಿಬೇಕು. This is single atom. So this is in case of solids. So next, what is energy band? So this is called as energy band. Then what is mean by energy band? The collection of very closely spaced energy levels. So this is the collection of very closely spaced energy levels called as energy band. So this is next. Second one is valence band. What is valence band? So it is the energy band which is completely filled at 0 Kelvin. 0 Kelvin ಅಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ ಆಗಿರುವಂತ ಎನರ್ಜಿ ಬ್ಯಾಂಡ್ ನಾವು ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಅಂತ ಕರಿತೀವಿ. therefore this is valence band. So this is completely filled with electrons at 0 Kelvin. So next, what is mean by conduction band? So this is the energy band, so lies above the valence band. ಸೊ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ನ ಮೇಲ್ಗಡೆ ಇರುವಂತಹ ಬ್ಯಾಂಡ್ನ ನಾವು ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಆಲ್ಸೋ ದ energy band due to the conducting electrons or free electrons. So this is called conduction band. Then what is mean by energy gap? It is the gap between valence band and conduction band. Valence band ಮತ್ತು conduction band ಮಧ್ಯೆ ಇರುವಂತಹ ಗ್ಯಾಪ್ ನ ನಾವು energy gap ಅಂತ ಕರಿತೀವಿ. If this energy gap is increases, the conductivity of a substance is decreases. If this energy gap is decreases, the conductivity is obviously increases. For example, energy gap of silicon. Silicon energy gap na ನಾವು ಬರೆದ್ರೆ 1.1 electron volt ಇರುತ್ತೆ. ಅದೇ ರೀತಿ energy gap of germanium. So that's 0.72 electron volt ಇರುತ್ತೆ. ಅಂದ್ರೆ ಇಲ್ಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಇದಕ್ಕೆ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ತುಂಬಾನೇ ಕಡಿಮೆ, ಅಂದ್ರೆ ಇದು ಕಂಡಕ್ಟಿವಿಟಿ ಜಾಸ್ತಿ. ಇದಕ್ಕೆ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ಕಂಡಕ್ಟಿವಿಟಿ ಕಡಿಮೆ ಇರುತ್ತೆ. ಆದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನೀವು ತಿಳ್ಕೋಬೇಕು. ಇಫ್ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಇಸ್ ಇನ್ಕ್ರೀಸಸ್, ಕಂಡಕ್ಟಿವಿಟಿ ಇಸ್ ಡಿಕ್ರೀಸಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ ಆಫ್ ಸಾಲಿಡ್ಸ್. ಸೊ ಎಕ್ಸ್ಪ್ಲೈನ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ ಆಫ್ ಸಾಲಿಡ್ಸ್ ಅಂತ ಕೇಳಿದಾಗ ಈ ಡಯಾಗ್ರಾಮ್ನ ಬರೆದು ಫಸ್ಟ್ ನಾನು ಹೇಳಿದ್ನಲ್ಲ ಆ ಥಿಯರಿ ಬರೀಬೇಕು. ಆಫ್ಟರ್ ದಟ್ ವಾಟ್ ಈಸ್ ಎನರ್ಜಿ ಬ್ಯಾಂಡ್, ವಾಟ್ ಈಸ್ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್, ವಾಟ್ ಈಸ್ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್ ಅಂಡ್ ವಾಟ್ ಈಸ್ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಅನ್ನೋದನ್ನ ಬರೆದು ಈ ಎರಡು ಎಕ್ಸಾಂಪಲ್ಸ್ಗಳನ್ನ ಬರೀಬೇಕು. ಅಲ್ಲಿಗೆ ನಿಮಗೆ 3 marks ಸಿಗುತ್ತೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ ಆಫ್ ಸಾಲಿಡ್ಸ್ ಅಂತ ಕೇಳಿದ್ರೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ಸಾಲಿಡ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ ಆಫ್ ಸಾಲಿಡ್ಸ್. So classification of solids, that is conductors, insulators and semiconductors. So what are the distinguish between conductors, insulator and semiconductor based on band theory of solids? So first of all, first difference is definitions. So what is the definition of conductors? Conductors are the substance which allow the electric current through them easily. So that is conductors. Insulators are the substances which do not allow the electric current through them. So semiconductors are the substance which having conductivity in between conductors and insulators. So that is called as semiconductors. ಗೊತ್ತಾಯ್ತಲ್ಲ, ಕಂಡಕ್ಟರ್ಸ್ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ನ ಈಸಿಯಾಗಿ ಪಾಸ್ ಮಾಡುವಂಥದ್ದು. ಇನ್ಸುಲೇಟರ್ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ನ ಈಸಿಯಾಗಿ ಪಾಸ್ ಮಾಡದೇ ಇರುವಂಥವು. ಸೆಮಿ ಕಂಡಕ್ಟರ್ ಅಂದ್ರೆ ಸರ್ಟನ್ ಟೈಮ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ನ ಪಾಸ್ ಮಾಡುತ್ತೆ, ಸರ್ಟನ್ ಟೈಮ್ ಅಲ್ಲಿ ಅದನ್ನ ಪಾಸ್ ಮಾಡಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರ ಅವುಗಳನ್ನ ಸೆಮಿ ಇನ್ ಬಿಟ್ವೀನ್ ಕಂಡಕ್ಟರ್ಸ್ ಅಂಡ್ ಇನ್ಸುಲೇಟರ್ಸ್ ಅಂತ ಕರೆಯುವಂಥದ್ದು. ಸೆಮಿ ಅಂದ್ರೆ ಪಾರ್ಷಿಯಲಿ ಅನ್ನೋದನ್ನ ಇಂಡಿಕೇಶನ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್, ವೈ ಕಂಡಕ್ಟರ್ಸ್ ಕ್ಯಾರೀಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್? Here, due to the energy gap. Here, in conductors, the valence band and the conduction band are overlapping with each other. Therefore, there is no energy gap between valence band and conduction band. That's why these substances carry electric current easily. So that is second difference, all about energy gap. In conductors, there is no energy gap, that is energy gap is zero because valence band and conduction band are overlapping with each other. In insulators, there is energy gap between valence band and conduction band is high, that is greater than 3 electron volt. In semiconductor, small energy gap, that is the gap between valence band and conduction band is less than 3 electron volt. So this is the main difference of conductors, insulators and semiconductors. Next, third difference, conductors having high conductivity. So this sigma represents conductivity. High conductivity nothing but about 10 power 2 Simon per meter to 10 power 8 Simon per meter. So insulators having less conductivity, so that is about 10 power minus 11 Simon per meter to 10 power minus 19 Simon per meter. Semiconductors having conductivity in between these conductors and insulator, that is 10 power 5 Simon per meter to 10 power minus 6 Simon per meter, is lies between conductors and insulators. So next, conductors are having low resistivity nothing but less resistivity, that is from 10 power minus 2 ohm meter to 10 power minus 8 ohm meter. Insulators are having high resistivity, so that is 10 power 11 ohm meter to 10 power 19 ohm meter. Sorry, this is ohm meter. Semiconductors having resistivity from 10 power minus 5 ohm meter, so lies between conductors, and to 10 power 6 ohm meter, so lies between conductors and insulators. Next, at room temperature, what about conductivity in semiconductors, insulators and conductors? Conductors are conduct even at room temperature. Even room temperature allu kuda conductors galu current na pass ಮಾಡ್ತಾ ಇರುತ್ತೆ. Insulators do not conduct current even at room temperature. Room temperature allu kuda ivu conduct ಮಾಡಲ್ಲ. But semiconductors are conduct current when temperature is increased. Temperature increase ಆಗ್ತಿದ್ರೆ ಮಾತ್ರ semiconductors ಗಳಲ್ಲಿ conductivity ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. For example, at 0 Kelvin ಅಲ್ಲಿ semiconductors act as a insulators, nothing but does not carry current. At room temperature, semiconductors act as a conductors, nothing but carrying current. So when temperature of semiconductor is increased, the conductivity is increases. Why ಅನ್ನೋದನ್ನ ನಾವು ನೆಕ್ಸ್ಟ್ ಇವಾಗ ತಿಳ್ಕೊಳ್ತಾ ಹೋಗುವ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ಸ್ ಈ ತರ ಇದೆ ನೋಡಿ. Why semiconductors act as a insulator at 0 Kelvin? Why semiconductors act as a conductor at room temperature ಅಂತ ಕ್ವಶನ್ಸ್ ಇದೆ. ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು ಎನರ್ಜಿ ಬ್ಯಾಂಡ್ ಬೇಸಿಸ್ ಮೇಲೆ. So this is valence band, this is conduction band. So first question ಗೆ ಆನ್ಸರ್ ಮಾಡ್ತಾ ಹೋಗೋ. Why semiconductor act as a insulator at 0 Kelvin? At 0 Kelvin, the valence band is completely filled with electrons. Conduction band does not having free electrons, nothing but completely empty. That's why semiconductor act as a insulator at 0 Kelvin. So question ಕೇಳಿದ್ರೆ ಏನು ಬರೀಬೇಕು? At 0 Kelvin, valence band is completely filled, conduction band is completely empty, nothing but there is no conducting electrons, hence semiconductor act as a insulators. Next, why semiconductor act as a conductor at room temperature? Second question ಗೆ ಆನ್ಸರ್ ಮಾಡ್ತಾ ಹೋಗುವ. Again, this is valence band, this is conduction band. So at room temperature, valence band is completely filled obviously, but conduction band is partially filled with electrons, that is free electrons. So there is a number of free electrons in a conduction band, hence semiconductor act as a conductor at room temperature. So room temperature ಅಲ್ಲಿ certain free electrons ಇರೋದ್ರಿಂದ conductor ಆಗಿ act ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. Next, third question. How conductivity varies with increasing temperature? ಇವಾಗ ರೂಮ್ ಟೆಂಪರೇಚರ್ಗಿಂತ ಜಾಸ್ತಿ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ವಾಟ್ ಅಬೌಟ್ ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ. If temperature is increases, then more number of electrons is jump from valence band to the conduction band. So then number of conducting electrons is increases in conduction band, hence conductivity is increases. So how conductivity varies with increasing temperature andre, so with increasing temperature conductivity is also increases in case of semiconductor, that is directly proportional. So temperature of semiconductor is increases, conductivity of semiconductor is also increases. Therefore conductivity of semiconductor is directly proportional to the temperature.